Welcome to talk number 7, which is the second of 2 talks about this theory known as energy wave theory by a guy called Jeff Yee. I talked about it last week, and then this is now sort of going into some of the other aspects of physics that the theory gives explanations for. So first in this talk, I'm just going to give some sort of overall thoughts on the theory, kind of why I like it or why things like this interest me, and my sort of take on like where the theory is at. Then we're going to look at what the theory says about time dilation, what it says about object contraction, its theory of electron spin and magnetism, electron orbits around protons, gravity, and then like a quick look at some of the maths of the theory, because most of the first part of the talk is going to be quite hand wavy and more based on ideas rather than concrete maths. And there is quite a lot of maths, which I won't go into, but I think it's worth touching on just to show that the theory isn't as hand wavy as I might make it look. So my thoughts on the theory in general, I think one of my sort of interests in physics is just the idea that what we are looking at, or what we think we are looking at, is perhaps not actually quite what we're really looking at. And that I think a lot of the breakthroughs in physics come from people taking a slightly new perspective on what it is that we're looking at. So I sort of quite like theories that take a step back and take a look at things from a different angle. And this theory very much does that. And it also attempts to bring together the sort of classical theories of physics that work at kind of normal scales that we use in everyday life with the quantum theory of physics, which works at very small scales, and it attempts to sort of unify those things. I don't see the theory as being entirely complete. I think it's kind of impressive in what it covers, and it's very interesting in some of the ideas that it brings together and some of the new explanations for them. But I don't see it as yet being like a viable contender against like general relativity or something. But I think it could get there, but it possibly needs some construction and some more of the pieces sticking together. But I think it may well have most of the pieces and a good portion of the instructions. And I think one of the things I really like about it is the fact that it makes physics physical again. So things like quantum mechanics are incredibly good at predicting things, but in order to do so, they often tend to sacrifice the physical explanation. So, for example, quantum mechanics has an equation for where to find the electron, or where you might find the electron around the proton. But in order to do so, it says, well, we don't really know how the electron orbits the proton. And the theory actually goes so far as to say, when you're not looking at it, it's in every position at the same time until you observe it. And we just have an equation for the probability of where that electron might be. So it creates some brilliant maths that does an excellent job of predicting something, but at the sacrifice of actually having a physical explanation for it. And maybe it's just that my brain doesn't like the lack of perceived reality, but I quite like this theory because it brings everything back into having a physical in 3 dimensions explanation again. So quick recap from last week. So the theory says that Adam's put his animations in a really stupid order, copy pasted something. The theory says that all matter is vibrations of this ether, this big universe jelly. And it says that the simplest particle is the neutrino, and that is basically a standing wave of vibration in the ether. So it has an inwards wave and an outwards wave that are of the same frequency, and because they're of the same frequency, you get a standing wave. So you then get stationary nodes on that wave. That wave just sits there in space, giving us the neutrino. Because it's a standing wave, and therefore it has stationary nodes on it, and those nodes are spheres, you can then sit the center node of one wave onto one of the spherical nodes of the other, and two neutrinos will stick together. And that then you can do that with three neutrinos, and then behind them in the third dimension you can stick a fourth neutrino, so you can build up these tetrahedron shapes. It says that the electron is a tetrahedron of 10, and it then says that one of those tetrahedron shapes will then effectively form its own kind of composite particle, which again has its own standing wave, and you can then build composite particles. You can make a tetrahedron of tetrahedrons, and that's the structure it uses for to represent the proton. And like I said, that tetrahedron structure in the middle there could be a tetrahedron of neutrinos if it's the electron, or it could be a tetrahedron of tetrahedrons. But either way, you get this kind of composite particle radius, and within that particle radius you have the standing wave, and then it says that beyond that you get traveling waves. As I mentioned last week, I'm still struggling to accept that idea of like the standing wave changing to a traveling wave at that particle radius, but lots of the theory is based on that, and if you accept that, some interesting things happen. So with that idea of the particle radius being the sort of the limit of the standing wave, and then beyond that there being a traveling wave, charge is then said to be an interference, either constructive or destructive, of those traveling waves, which look transverse here, but they are longitudinal, so they are still a sort of expanding and contracting beach ball type wave. So that's the recap. Now let's have a look at what this theory says about time dilation. So before we do that, need a quick detour to do some maths, which is some math about averages. So this is the mean average that we all know and love, which is that if you have two numbers, A and B, the average of those numbers is given by adding them together and dividing by 2, because there are 2 of them. Or if you've got 3 of them, then you add A, B, and C together and divide by 3 because there are 3 of them. So that's our normal mean average. But there is also a geometric mean average, where if you take 2 numbers A and B, you get the geometric mean by multiplying them together and then taking the square root, i.e. the second root, because there are 2 of them. And if you've got 3 numbers A, B, and C, you get the geometric mean by multiplying them together and taking the third root of them, because there are 3 of them. And according to Wikipedia, this is particularly useful for computing means of speed-up ratios, because if you have a mean of half as fast and twice as fast, the geometric mean will give you 1. So with that little detour on averages done, we can come back to our particle and its waves emanating from the wave center. So it's this standing wave with waves coming in and waves coming out. And if we say that the experience of time of a particle is given by the rate at which that particle center receives inward waves, then we can say that the rate at which it receives inward waves when that particle is stationary is just the frequency of those waves. So the frequency in is just the frequency that those waves are happening at. If we then move that particle through space, the waves continue to go in and out, but they get squashed up on the leading edge and they get stretched out on the trailing edge. So then, because these waves are traveling through the ether and the speed of wave propagation is the speed of light, represented as c, then the speed or the frequency of waves on the lagging edge is given by the frequency of the waves divided by 1 minus the speed it's traveling, v, divided by the speed of light, c. And the speed, or sorry, the frequency of the inward waves on the leading edge, where they're getting squashed up and those waves will happen faster, is given by the frequency multiplied by 1 plus the velocity divided by the speed of light. If you then take the the geometric average of those leading edge and trailing edges, you get a resultant geometric inward mean frequency, which looks like this, which then, if you just do some algebra to rearrange it, looks like this, which is then the original frequency multiplied by this familiar thing, which is the Lorentz factor, which is the well-known time dilation factor. I think we could question whether it's valid to use a geometric mean to do this, but I think the fact that we can ask that question is kind of part of the fact that the theory is a physical theory, and therefore you can ask questions like, but why does that physically happen? Whereas in a theory like quantum mechanics, where the physical aspect gets slightly dropped, you can just sort of have an equation and say this equation predicts it. So I like the fact that, as with the theory we looked at in an earlier talk, the idea that everything is made of photons, this theory similarly gives an explanation that ties in with special relativity for time dilation. And that theory is based in the physical idea that time is what happens in objects, rather than time being a sort of medium that you travel through. So we can also do something similar with length contraction. So as mentioned in an earlier talk, when objects travel at speeds comparable to the speed of light, those objects contract in the direction of motion. So again, we can do something very similar. If we say we've got this particle, if this is a typical atom with that sort of composite proton in the middle and an electron flying around the outside, then effectively the size of that particle is determined by the radius. The size of the proton and the electron are almost immeasurable in comparison to the size of the particle itself. They're not immeasurable, but they're tiny. So effectively, the size of the particle is proportional to that radius. Then when we make the particle move, that radius gets squashed on the leading edge and it gets stretched on the lagging edge. And again, we can calculate the changes in those radii. I'm still using f for frequency here, but given that frequency and wavelength are just inversely proportional to each other, it's essentially the same calculation. Again, we use the geometric mean, we end up with some very similar looking maths. Like I said, wavelength inversely proportional to frequency. And so again, the conversion factor, or the length contraction factor, is again the Lorentz factor, as it is well known. So some lovely physical explanations for things shrinking at high speed. Now we get into electron spin. So electrons are known to have a very weird thing known as half spin. And that is because if you take an electron, I have no idea how somebody does this, but if you take an electron and you turn it around 360 degrees, it is no longer back where it started. You have to turn it around twice before it gets back to its original position. I don't know how somebody does that, because I don't know how you hold an electron in your hand, but this is a very well established fact that electrons have to rotate 720 degrees before they return to their original position. This graphic sort of illustrates one way of trying to conceptualize this. If you sort of attach a strap to every side of a cube, you can make it so that that whole configuration doesn't return to its original configuration until you've rotated it 720 degrees. So it's known as half spin. Another weird thing about electron spin is that if they were actually spinning, they would be spinning faster than the speed of light. So conventional physics says that electrons can't actually be spinning because that's kind of impossible. So we have this idea of spin, and they have this magnetic moment, and their magnetism is related to their spin. And there's this idea that you have to rotate them twice to get them back to where they were. But at the same time, we say, I can't actually be spinning because the maths would make their angular velocity faster than the speed of light. So energy wave theory has a take on this. So it says that the electron is made of 10 neutrinos in this tetrahedron pattern. And I've just marked the centers of those with the purple dots. So then you can see that the centers of those second two neutrinos can sit on wavelengths or on nodes of the first one. And the same is true vice versa. They can all sit on each other's nodes. And because this distance is the same as this distance, the same is true of the next set down as well. So it's true down the right-hand side and it's true down the left-hand side, but it's not true down the middle. That purple doesn't show up very well, but you can see that that bottom neutrino, its center does not sit at the same distance as the others. And if I got my trigonometry right, the ratio of those distances will involve the square root of 3, which is just not a rational number. So you're not going to be able to get those the wave node of the center of the bottom neutrino to sit on a wave node of the waves from the top one. So there's this sort of inherent tension in that structure. So energy wave theory says you've got this bottom neutrino and it's experiencing a force from the waves of the top one, and that force causes the electron to on its own want to spin. When I first heard this, I was like, oh, that's interesting. And then I sat and thought about it for a while, and I thought, well, hang on, isn't the same thing true in this direction? So it's not the bottom one that wants to move, it's the one on the right-hand side. And you can also think of it, looking at it from this direction, and you can say, well, it's not that one that wants to move, it's this one that wants to move. And so then I thought that actually this same thing is just true along all 4 faces of this tetrahedron, and you've just got a whole set of even forces, and that nothing's going to move at all, and the electron won't spin. And then I thought about it some more, and I thought those forces aren't necessarily static because everything is waves and waves are movement. So those forces are going to be almost like oscillating. And then I thought, oh, what if they're not oscillating at the same, on the same phase, on every face of it at the same time? And then my brain hurt too much. So for the moment, I'm open to the idea that this might be plausible. And if we hold the idea that it might be plausible and accept what the theory says, the theory then says that you've got this sort of inherent force or forces acting within the electron, causing it to spin on its own, but that because those forces are acting at strange angles along all the faces, the electron doesn't just spin in a normal way, it spins a bit more like if you were to spin a coin on the table and then let that coin stop spinning, that it sort of spins in this kind of wobbly way. And therefore, maybe it takes 2 rotations to return to its original position rather than 1. Out of that spin, the theory then says that not only is the electron emitting its longitudinal waves in its sort of expanding and contracting beach ball sense, but that it also creates this kind of vortex from the fact that it is inherently spinning. And it's this vortex, which is a kind of, calling it a transverse wave, because it's not longitudinal, it's not just out and back, but essentially a kind of spiral wave created from the spinning of that electron. And that it is this wave that the theory calls magnetism. Now, as I mentioned earlier, the theory says that when you get a particle made of many particles, that their waves combine to give this sort of composite wave, and you get this larger standing wave. So here we've got 10 neutrinos, and then their standing waves essentially combine to create a bigger standing wave, and you get a larger boundary. In other words, the radius that we see as being the radius of the particle is much larger than the radius of the tetrahedron itself. And so my take on this is it also possible that when we measure or calculate the rotational speed of an electron, we're measuring it based on that conventional radius of an electron, and that is not actually the bit that's spinning. The bit that's spinning is the bit in the middle. And therefore, if we did the maths again, might it be that the electron could actually physically be spinning and yet still not be spinning faster than the speed of light? So the theory says that electric charge is the traveling longitudinal waves coming out from the particles as their beach balls expand and contract and push against each other, and that magnetism is a transverse sort of vortex wave that comes out of something spinning. And the idea that an electron's magnetism comes from its spinning is the current view of it, the current conventional view. So then we get into some more fun hand-wavy ideas about electron orbits. So as I mentioned earlier, quantum mechanics says that electrons don't actually exist in any particular place in time until you observe them, but they just have this probability cloud of where they might be around the proton. Energy wave theory says they do have a probability cloud, but they are actually physically orbiting. They're just not physically orbiting in a perfect sphere. So it says that you've got this, if you've got a proton on the left and an electron that is orbiting it on the right, the proton is positively charged and the electron is negatively charged, so they have an attractive electric force, which the theory says is due to phase difference. I did mention my skepticism on phase difference last week, because phase difference changes depending on the distance, but leaving that part of the mind open to accept it, it says that there's an attractive electric force and that there's a repulsive magnetic force. I also have skepticism about why the magnetic force should always be repulsive rather than not sometimes being attractive and sometimes being repulsive. I did email Jeff Yee about that, and I'm still having an ongoing conversation with him over email, trying to either get my head around or get his head around exactly why that happens. But the theory says there's an attractive force and there's a repulsive force. And magnetism, the strength of magnetism decreases with the cube of the distance. So that top graph is a 1 divided by x cubed graph. So it tails off as the distance left to right increases. It tails off with a 1 over x cubed. But the electric force decreases with the square of the distance. And I've written the electric force going below the graph because it is attracting the two objects together. So it's acting in the opposite direction of the distance between them. So you've got magnetism decreasing with the cube of the distance, electric force decreasing with the square of the distance, but they're acting in opposite directions. And so there is some point, there is some distance at which those two forces exactly cancel each other out, which on this graph happens to be at 1, just because of how I plotted the graph. So the theory says that there is a distance from the proton at which the electron is equally repelled by the magnetic force and attracted by the electric force, like so. But you notice that the proton itself is a tetrahedron structure, and therefore the theory says that the forces emanating from it are not exactly the same at every position around it. So the proton itself is a tetrahedron which is spinning, but depending on whether the electron is aligned along the nodes of two nodes of the proton or not, it will experience a slightly different strength of force, and therefore the electron takes an odd path around the proton, and therefore it gives this kind of not quite spherical orbit, and hence you get the strange probability cloud of where it might be at any moment. So now we can go into the really wild stuff, which is gravity. This theory is well, you can make of it what you want. I think it's a sort of nuts idea, but I think Einstein once said any idea that's not absurd doesn't stand much chance. So let's have a look. So the theory says that you have a particle and it is this standing wave, so it has in waves and it has out waves. But because the particle is spinning, it's therefore got this vortex wave coming out of it as well. And therefore, that vortex wave is essentially emanating energy out of the particle. Or maybe a better way to put it, all of the energy which comes in the longitudinal waves doesn't all go out through the longitudinal wave. Some of it goes out through this transverse vortex wave. And therefore, again, we're representing longitudinal waves using squiggles here because they're so hard to draw in 3 dimensions. But you've got the in waves and the out waves, and the out waves, the longitudinal out waves, have a slightly smaller amplitude than the ones that came in, because some of that energy is going out through that vortex wave. And the theory says that this creates a shading effect. In other words, if you've got 2 particles or 2 objects, they have got waves coming in from all the other particles in the universe all around them. And if we just give those inward waves an amplitude of 1, then those particles are experiencing a force that is equal in every direction, except where one particle is shading the other particle from those waves, and the waves that are coming in between those 2 particles are the reduced outward waves that have that slightly smaller amplitude, and therefore the forces acting between those particles are very slightly less than the forces acting from all other sides. And therefore it says that gravity is this shading effect where the particles are not so much attracted to each other, but are more forced towards each other by by the lack of repulsion. I don't quite know what to make of that theory. Part of me is like, that sounds silly. But he does go into the maths of it, and he makes the maths of it add up really perfectly, which if we've got time, I might whiz through. But that's the theory of gravity, according to energy wave theory. So that basically concludes the ideas that I've managed to put together into slides from this theory. It does cover lots of other things. It covers forces. As I mentioned before, there's like a periodic table of particles. There's stuff about the energy of all the different particles. There are various calculations he's done on things. I haven't really covered any of the maths. I've just done some hand wavy conceptual stuff, but there is a whole bunch of maths in this theory. There is an equation for the energy of a wave that can then be split into two forms: the longitudinal beach ball particle energy on the left and the transverse photon energy on the right. He also goes into equations for the magnetic force, the gravitational force, the strong force, which is in this theory sort of variation of magnetism. There is a bunch of maths in there. You can go to energywavetheory.com/equations and try and get your head around it all. I'm just going to go through one bit which relates to gravity. I realize sort of pushing against time here, so I'm going to whiz through this. This is Isaac Newton and his equation for the force of gravity, which is this constant g multiplied by one mass multiplied by the other mass divided by the distance between them squared. So it contains this number g, which is 6.67 times 10 to the minus 11. Einstein's theory of general relativity contains exactly the same constant. It exists in both. There is a bunch of stuff in energy wave theory which takes the amplitude of that inward wave and the amplitudes of the two separate out waves. It then uses the mass of the electron, then converts that to energy using E equals mc squared, to take the same equation and stick the c squared in it. I'm going to whiz through this really quickly. It gets an equation for the electric force, which is basically derived from the equation on the previous page. It then takes some stuff from one of the earlier things, and it creates a ratio of that difference between the longitudinal in waves and longitudinal out waves. It equates that difference to the ratio of the strength of the electric force and the gravitational force. It then uses that to derive a gravitational force between two electrons, and then it takes that and equates it to Isaac Newton's equation for gravity, which is in the top right, and it derives that gravitational constant. I don't think he's the first person to do that. I think you can derive that gravitational constant anyway without this theory, but I do think it's interesting that despite the theory of gravity looking potentially totally nuts, that he does actually take his wave equations and he does like work it through and show the stuff adds up. There's a video on that which talks through those equations that I've just skimmed over. And again, if you want to go to energywavetheory.com and look at the equations and scrutinize them, then that is the link. That is a bit over time. Apologies for that. But that is the end.